thank you guys. Thanks so much for having me. This is great. My name is Maksim Pecherskiy. I'm the Chief Data Officer for the city of San Diego, as that big slide says above. And we did change the title of our slide a little bit, because I really wanted to talk about how we can suck less data, just overall. And so I'm going to talk a little bit about the road that we have gone through at the city of San Diego to do a little bit less sucking, and we're still not great. So what data does the city have? What does it manage? What does it do? As you can see here, there's a lot. There's trees, there's street lights, there's traffic lights, there's businesses, there's trash cans, there's bike racks, there's street paving. All of that is managed by one large conglomerate organization, which in our case is 36 different departments. Oh no, how do I go back? I can't go back. Oh no. That other slide was all about, yes, it works. So this slide is about all the things that give us data. So all the things that have sensors on them. So our police cars, our fire trucks, our trash trucks, our traffic lights, our parking meters are all giving us data continuously. But really, for as much data as we have, the dirty secret that a lot of cities have is that they all kind of suck at using data, really. And so my team's job is to suck less, is to help residents and employees suck less at using data. And we've been somewhat successful. We've gotten this award, this What Works Cities Silver Award from Bloomberg that we got certified. We recently just won another award from Equipped to Innovate Governing Magazine for being the #1 data-driven city in the country. That's my boss taking credit for it. He's awesome, by the way. So I guess that just means we suck less than everybody else, right? So what do we really do besides just say the word suck over and over in a presentation? Really, we help residents and employees get and use data across the city. So what does that really mean? We kind of break that down into how we think about it. So getting data means knowing that it exists, right? Knowing that this data is available somewhere, being able to find it, and then being able to get it into your hands, being able to get that shapefile, that GeoJSON, that spreadsheet into your hands. So now you have it in your hands. What do you do with it, right? You need to be able to understand it. You have a spreadsheet with 100 columns. What do all those columns mean? What are the caveats in the columns? And then if you're looking at a spreadsheet with a bunch of data, generally you don't already have a question formulated in your head, right? So how do you formulate an intelligent question around the data? Then you have a question. How do you go from question to answer? And then how do you take that answer and actually change your business process, change your service, make a decision? So most people think we do this all day, which would be awesome. Really, we do this all day. And this is kind of why. So I've been at the city for almost 4 years now. My job started with the open data policy. So the open data policy, I had to go to council the first 2 weeks on my job. It was terrifying. And the policy really created that structure for understanding, okay, what do we have, where is it, and let's make it available. So what do we have? I worked with 65 people across our 36 departments to do a data inventory in 2015. And just to be able to understand what data does the city have, believe it or not, this was the first time this was done citywide. We also asked, great, you have it, where is it, right? And for most of you people in this room, I don't think this is groundbreaking, but this really was groundbreaking at that time. And this is where our data lives. We have hundreds of data sources that I would consider primary data sources for data. We have files on shared drives. We have 3 versions of Oracle. We have systems that are older than me, and I'm not going to say how old I am. We have SQL Server databases. We have multiple instances of SAP. We have IoT devices like parking meters. We have software as a service applications. We have human beings that sometimes store data in their heads. So how do we get it out, right? And how do you make that available across the city organization? And because of the way cities work and because of politics, the best way to do that is with an open data portal. And that's exactly what we did. This is the second iteration of our open data portal. It's custom built. We're pretty proud of that because it costs us way less than most other data portals cost. And here's a shameless plug for the blog that we run on the Open Data Portal. So now the data's out on the portal. How do we know that the data you're picking up from the portal is correct, right? And that's really where we come in. We work to make sure that the data portal is the one source of truth. So by the time you're picking up data from the portal, you know that it's vetted by our team, that our team has engaged with the department, done all the necessary cleaning, and taken that data to the best state that it can be, so that the stuff that gets built on top of it, the accuracy is much more likely to be there. So then, if we have to do all this work over and over again all the time, right, how often do we update data sets on the portal? Which gets us into the concept of delivery and automation, which is another thing that our team does. And here's how I'll explain this. So we built this thing called streets.sandiego.gov. It was really cool. It was basically, at first it was a political stunt that became an operational tool, which is great. Do not tweet that, please. Thank you. And we actually won an award for it from the American Public Works Association. In case you are not familiar with the American Public Works Association, they give awards for bridges and libraries and tunnels. So we are in the under $5 million category, and we were the only thing that was actually just software. So we didn't have competition. But when we were building this thing, the people that we were working with, the streets engineers in the department, they weren't too happy with us because we were asking them for data. Hey, can you give us an updated set of data? Hey, can you give us an updated set of data? They were not happy with us at all. They hated us. And as we dug a little deeper down, we started to realize this is why they hated us. This is page 1 out of 5 of their process to get data to us. And the data they were getting to us was actually the same data they were having to make reports on to a conflict mitigation system that makes sure that multiple departments don't dig up the same road within the same week. So obviously, we're just asking them to do more work, and it's inconsistent work, and it sucks, and they're streets engineers. That's not what they signed up to be doing. So this is what it looks like when we actually put it into a diagram. This is what their process looks like. So we're trying to understand how we can actually write the ETL. So what do we have? We have a shifting source of truth, right? Because I don't know about you guys, but I cannot do 40 manual steps in Excel the same way every single time, every month, even if it's written down. There's nuances that are hidden in people's heads, and it's time consuming, it's irreplicable, it's unstable, it's error prone, it's no fun. And really as we were going through this, what it came down to is trying to understand, well, what do the columns mean that you're doing this? How do you clean the data out? What are the things that you remove? What are the different values in the columns? And we brought in this tool called a data cataloging tool. It's called Lation Catalog. And it sits there, and it connects to our databases, and it reads the query logs, and it tries to understand what data is relevant, how often it's used, what does it mean, and the stuff that it can't understand or the stuff that needs to be corrected, human beings go in and modify it. And it's a carrot and a stick approach, or actually just a carrot approach, because we also use this tool to kind of let them have access to data in the database and run SQL queries against it. So they're incentivized to make sure that this data is right. Once we figured out what we actually needed to pull and how we needed to pull it, we brought in another tool called Poseidon. We like code names because they're fun and they sound cool, but really, it's just Airflow. And Airflow, that's not a code name, that's an open source project originally developed by Airbnb to move their data around. And really you can say that it runs a bunch of Python jobs on a schedule dependent on each other. And so we were able to turn this whole process that takes about 20 to 40 hours once a month, we're able to run it in less than 3 seconds every night, executed by a machine, right? And everybody's happy because the streets engineers, they don't have to do this anymore, and they don't want to do this anymore. They want to make street stuff. But then the next question was, okay, well, hey, can you just tell us when you update it? They're like, yeah, sure, like we're already running Python jobs on a schedule. Why don't we just send you an email, right? that was awesome. People got really excited about it. And then the next question was, well, will you let me know when I need to deal with it? Will you let me know when this becomes a problem and I actually need to take care of it, other than just like mindlessly looking at a report every day? I'm like, well, sure, we can, again, send you an email. And that's when we kind of started thinking, you know, data for the sake of data is great, but it needs to become actionable. And so we built a lot of tools in the city that make it actionable. So performance.sandiego.gov is another example of one of those tools. That's all of our city key performance indicators, some of them automated, some of them not, but they're getting pulled into one place. They're shown on a graph where people can actually make decisions and change their sets of operations around the key performance indicators. Streets.sandiego.gov I already mentioned. Budget.sandiego.gov takes highly complex, multi-dimensional public budget formulation system from SAP, makes it into charts so that the city council and the residents and internal people can explore what our upcoming budget is as compared to our previous budgets, how we're changing it, why we're changing it, things like that. Another request that we started getting is, can you help me tell a story? And that's where we kind of got into, okay, well, now we're making maps, right? So this is an example of a street sweeping map. Street sweeping became a contentious problem in the city of San Diego for a little while. Totally first world problems, but hey, it's all good. Don't tweet that either, please. And you know, we've helped to visualize street sweeping and the street sweeping schedule so that people can understand when their street's gonna get paved. And we had a lot of these projects, but then we were kind of started getting to the point of like, we're getting bored, right? Like, I want to put data on the maps, right? It's fun, but really what we need to do is we need to expand this whole thing. We need to teach people how to catch their own fish. And that's what we started doing. We bought some Tableau licenses and started giving those to people internally. We also created this PandaPack Data Lab, which is an operating system on a flash drive. It's really interesting. PandaPack's the flash drive. Data Lab is something new we're trying out on top of Google's Cloud Data Lab. And CARTO was actually a big part of these initiatives, right? Because we wanted to let people build their own maps, do those simple geospatial operations, put points in a map, put lines in a map, tell a story, figure out how many trash cans are in the business improvement district, figure out, you know, tree canopy assessment, what I call, you know, and I just simply don't have a better word for it, but simple stuff. It's not simple, but it's stuff that you don't need advanced analytics capabilities for. So why do we do this, right? Because what, we're lazy? Well, we are very lazy because we're programmers, and that's what programmers do. But really, we just want to work on the hard stuff. We want to work on structuring projects that, you know, the average city employee can't do or shouldn't do because really that's our job. And so the way that we think about structuring projects like this is we let machines do what they do best so that humans can do what they do best, right? We want to empower humans to really use those decision-making capabilities, and we want to let machines run things on a schedule because they're great at it. And the way that we think about it is, I know it's a little abstract, but we take raw data, we really go after raw data. We do direct connections to data sources. We perform static analysis on it, that initial sets of analysis. We integrate it into dynamic systems that run it on a schedule, and then the last part is probably the hardest thing, is we actually influence service change. So we change the operations in the city. And what that does is lead to better outcomes using same resources. So that sounds really nebulous, right? Here's an example. So we took risk claim data, and you know, city gets sued all the time. And we try to understand how, what are the patterns to the risk claim data, and we try to feed that information back to the departments that would be in charge of fixing these claims. So if there's a claim that's filed in an area where there's a high risk of being sued, then we'll let the department know about it. Whether they go and choose to fix it or not, that's up to them, but we provide the alert. The other thing that we did is parking meter utilization. So we have about 5,000 parking meters. Those parking meters take time, cost to maintain. People have to go walk, pull stuff out of those, right? If there are parking meters on the street that are not making any money or that are ineffective, we want to know about it so we can move the parking meters in an area where they're going to be effective. So this was a parking meter utilization project. This is not a screenshot we actually built. This is from the Mapbox blog, I think, but there's just like no screenshot for the thing that we did. We have trucks that move around city facilities delivering stuff, about 9 trucks every day. Each of those trucks has a set of routes. What we did is we reprioritized those routes, and we're able to save the truck driver an average of an hour to an hour and a half per day on their route, simply by changing the order of where they're going. Another thing that we did is we did EMS dispatch reprioritization. So when you pick up a phone call and say that my knee hurts, they ask you a bunch of questions, you get a code. Based on that code, you get a dispatch plan. So either you get like a fire truck and an ambulance with lights, or maybe you just get an ambulance with no lights, or maybe they tell you, screw you, go take an Uber. And so what we did is well, actually don't tell you that, but I think they should. And so what we did is we changed those dispatch plans. We looked at the trucks getting dispatched and what happens when they're on scene. We compared those, and we worked with the doctors in our EMS department to change those dispatch plans. So we are sending the right amount of resources to one type of call, and we're not over dispatching certain type of calls, and we're not under dispatching certain other types of calls. We also did a thing with sensor placement. We have 3,200 City IQ nodes going up with a bunch of sensors in them. One of the reasons that they're going up is to help with our Vision Zero efforts. And what we did is we made sure that those are going up around intersections that have a high impact to our Vision Zero program. And then lastly, as Flo mentioned, we are working with CARTO and Waze data to provide real-time traffic monitoring in our traffic operations center. So the end goal with that is to take our traffic lights, put them along with the Waze data, and allow our traffic engineers to change the timing dynamically and see the impacts of that, and also understand which traffic lights are currently out and dispatch crews accordingly. That's a really long-term goal because there's a lot of ETL that has to be written for that, but one day. So just to do a little bit of a recap, we give you stable data, right? That's kind of the most important thing, that you can find and that you can understand, and you can understand what it means. We make sure that it's up to date and that it's continuously updated. We help you use it so that you can go and build your charts, you can make your map, you can change your operations, you can get your alerts. And meanwhile, we work on the hard stuff, the stuff that is harder to solve. So what, right? What have we been able to do in the past three and a half years? We are now the central source of where city people go for data. The departments that would typically not share data with each other, would typically not collaborate with each other, now go through us, and we make those connections. We've had a lot of cost savings and time savings, obviously. And these are pseudo metrics, but these are metrics we think about all the time. But we've been able to reduce the amount of time it takes somebody to get their hands on data, and reduce the amount of time that it takes someone to go from I have a bunch of data to I have an answer. So I guess we suck less now, right? Maybe, sure. I think we can always be better. And in the future, the things we have coming up are, we're going to be doing a lot more mobility work. We have a climate action plan, a very aggressive climate action plan to decrease our emissions. We have various Vision Zero initiatives that will be coming up. And we have, as I mentioned, we have those traffic IQ nodes, sorry, not traffic IQ, city IQ nodes that are coming up that will be providing us with pedestrian counts and car counts and all of that stuff. We'll also be improving our AVL system, which is very exciting. And that's it. That is a picture of my cat. His name is Clifton.